Welcome. In this explainer, we're going to do something a little different and I think really powerful. We're taking just one question from a GCSE Physics paper, question 06, and we're going to crack it wide open to show you exactly how to lock in every single mark.
It all kicks off with this classic physics puzzle. You see an egg dropped into soft foam, and it doesn't break. But why? Well, this little demonstration is actually the key to a whole multi-part exam question. So let's get right into it.
Okay, let's dive into the very first part of the question. For just 1 mark, they're asking for a simple definition of a really fundamental concept in physics: inertia.
So here's the exact wording. Now notice they give you a massive clue right there by connecting inertia to mass, but you still need to give that precise textbook definition to bag the mark.
And there you have it. That's the golden answer, the exact phrase the examiners are looking for. It's really all about how much an object resists changing what it's doing. If it's sitting still, it wants to stay still. If it's moving, it wants to keep on moving just like that.
So the crucial point to get your head around is that inertia is basically a measure of how hard it is to change an object's motion. And, as the question hinted, it's tied directly to mass. More mass means more inertia. That's why it's a lot harder to push an 80-kilogram adult on a swing than it is a 40-kilogram child. Simple as that.
All right, on to part 2. This is where we start connecting all the dots, linking inertia to forces and momentum, and bringing it all back to our unbroken egg.
Now, look closely here. 3 marks. That is a huge signpost from the examiner. It's telling you they want a clear step-by-step story. You need to connect the cause, the soft foam, to the effect, the egg surviving. One sentence isn't going to cut it here.
And this is the perfect 3-mark answer. Each of these steps gets you 1 mark. First, you state the obvious but crucial fact. The foam increases the time it takes for the egg to stop. Second, you link that longer time to a smaller rate of change in momentum. And third, you bring it home with the physics principle. Because force equals the rate of change of momentum, a smaller rate means a smaller force on the egg. That's why it doesn't break. Beautiful.
And hey, here's some good news. The mark schemes aren't always super strict on the exact wording. Instead of saying decreases the rate of change of momentum, you could also say it decreases the deceleration and still get that mark. The absolute key phrase, though, is at the end. You have to clearly state that the force is reduced.
And now for the calculation. This is a big one. It's worth 4 marks. That means showing every single line of your working is absolutely essential if you want to get all the credit you deserve.
Okay, let's break down the scenario. We've got our key pieces of information: a mass of 32 kilograms, a time of 180 milliseconds, and a force of 800 newtons. The mission: find the velocity of the child just before they landed. Let's do this.
Step 1, your first port of call, always, is your physics equations sheet. You're looking for the right tool for the job. In this case, it's this beauty, the equation that connects force, momentum, and time. This is the foundation for everything that comes next.
Whoa, hold on a second. Here it is. A classic exam trap. The time is in milliseconds, but your equation needs seconds. You absolutely must convert it by dividing by 1,000. Just doing that one simple conversion correctly banks you 1 of the 4 marks right away.
Okay, next up we need to find the change in momentum. So we just shuffle our formula around a little bit. Change in momentum is simply the force multiplied by the time. Now we just plug in our numbers, 800 newtons times our converted time, 0.180 seconds.
You punch that into your calculator, and out pops the answer, a change in momentum of 144 kilogram meters per second. We're so close now, just 1 more step to go.
And now for the grand finale. We know that momentum is just mass times velocity. Since the child came to a complete stop, their initial momentum is the same as the change in momentum we just figured out. So to find that initial velocity, we just rearrange the formula. We divide the momentum by the mass. That's 144 divided by 32, which gives us our final answer, 4.5 meters per second. And by showing every one of those steps, the equation, the conversion, the rearranging, and the final calculation, you have just secured all 4 marks. Job done.
So there we have it. We've completely taken apart an entire 8-mark question. But what are the big strategies we've learned that you can use on the rest of your exam paper?
Well, it really boils down to this. First, know your definitions. Know them cold. They're often the easiest marks you'll get. Second, when you see an explain question worth a few marks, think like a detective telling a story. What happens first? What does that cause? And what's the final result? Third, always be on high alert for unit conversions. It's such a common way they test your attention to detail. And finally, for any calculation, write down everything. Even if you mess up the final number, you can still get tons of marks for your method.
And that is how you deconstruct a question to guarantee you're getting every possible mark. So, I'll leave you with a final thought for your own revision. We've touched on inertia, forces, and momentum here, but what physics principle do you think is the most misunderstood or trips people up the most? Finding your answer to that is the key to your next study session.